here we have a calculus problem on related rates. Okay, let me go with the information. Air is being pumped into a spherical shaped balloon at the rate of 5.4 cubic inches per minute. Find the rate of change of the radius when the diameter is 6 inches. Okay, so here the air is being pumped into a spherical shaped balloon. So when air is being pumped, the volume of the balloon will increase. So and also it is given that the shape of the balloon is spherical. So we can use the formula to find volume of a sphere to get the volume of the balloon. So let me say that this V represents the volume of the balloon. So since it's a spherical shaped balloon, we can use the formula to find volume of a sphere. That is 4/3 times pi r cube. So this r represents the radius. So when air is being pumped, the volume of the balloon is getting changed. So change in a quantity we can represent using derivative in calculus. How? So it is given that the balloon, air is being pumped at a rate of 5.4 cubic inches per minute. So that means the volume of the balloon is getting changed. That means increasing 5.4 cubic inches per minute. Every minute it increases by 5.4 cubic inches. So that means volume is getting changed with respect to time. So how do you have to write this one as a derivative? So that's very simple. dV over dt. So the dV says a change in volume, and we write dt in denominator. That is change in volume with respect to change in time. So that means here we find derivative on both sides with respect to time. So now let me find the derivative of this stuff over here on the right side with respect to time. So 4/3 and pi, both of them are constant. I'm pretty sure r is a variable because r does not have a constant value, because when r is being pumped into the balloon, so the radius will increase. Since this r is increasing, so it's a variable. Okay, now when I find derivative of this r cube with respect to t, so first what I have to do is I have to bring this exponent in front of the variable. So using the power of derivative, that is 3 times r square. So I just got the exponent in front of the variable and subtracted 1 from the exponent using the power of derivative. So far I have completed derivative only for the exponent we have over here. By chain rule, I have to further derivative for the base r with respect to time. So when I do derivative of this r with respect to time, it will be dr over dt. So also here I have just kept this 4/3 and pi as it is because both of them are constant. When I find derivative, whenever a variable is multiplied by some constant, I have to keep the constant as it is, and I have to find the derivative of the variable alone. Now let's do some simplification over here. There is 3 over here and 3 over here can be cancelled. That is 3 goes into 3 one times. Here also 3 goes into 3 one times. Then I'm getting dv over dt equals to, so 4 pi times r square, which is 4 pi r square times dr over dt. In this equation, my aim is to get the value of dr over dt, that is change in radius with respect to time. So that's what we have to find according to the question. That is find the rate of change of the radius when the diameter is 6 inches. Since my aim is to find the value of dr over dt, I have to plug in the values for dv over dt and this r. So dv over dt represents a change in volume with respect to time. So according to the question, it's 55.4 cubic inches, because the question clearly says air is being pumped into the balloon. So when air is being pumped into the balloon, so the volume of the balloon is getting changed, that is increasing at a rate of 5.4 cubic inches. Since the volume is getting increased, we have to take this value with positive sign. In case if a quantity is decreasing, we have to take it with negative sign when we do calculation over here. Since the volume is increasing, we can take this 5.4 with positive sign. So we have to plug in 5.4 for this dv over dt. So then 5.4 equals to 4 pi. Now I have to plug in value for r. And the question clearly says we have to find the rate of change of the radius when the diameter is 6 inches. If the diameter is 6 inches, then what is the radius? Radius is 3 inches. That is, we have to find the rate of change of radius. That is, we have to find the value of dr over dt when r is equal to 3. So now we can plug in this 3 for r over here. Then I'm getting 3 square times dr over dt. So 5.4 equals to 3 square is 9. 9 times 4 is 36 pi times dr over dt. Okay, let me write the stuff over here. 5.4 is equal to 36 pi times dr over dt. Since my aim is to find the value of dr over dt, I have to get rid of this 36 pi, which is multiplied by dr over dt. So let me divide both sides by 36 pi. Let me write it. So when I do so, this 36 pi will cancel out. So I'm getting 5.4 over 36 pi equals to dr over dt. Okay, here in numerator we have a decimal. Let's try to get rid of this decimal point. So for that we can multiply both numerator and denominator by 10, so that we will be able to get rid of the decimal point. So let me multiply 10 over here and 10 over here. Let me write it. So when I multiply 5.4 by 10, I am getting 54 over 36 pi times 10 equals to dr over dt. So both 54 and 36, the greatest common divisor 18. So 18 goes into 54 3 times, 18 goes into 36 2 times. So now I'm getting 3 over, so 2 times 10 is 20 pi equals to dr over dt, or we can write it like dr over dt is equal to 3 over 20 pi. And now we have tried the unit for this one. So since when air is being pumped into the balloon, volume is increasing. Since so it represents volume, it has been expressed in cubic inches. But how we express this radius? Radius will be expressed in inches. So the time is same per minute. So here we have dr over dt. So the unit of this radius is inches and the unit of this time t is minute. So we have tried the unit for this one as inches per minute. So that is the rate of change of radius is 3 over 20 pi inches per minute, or in other words, the radius is increasing at a rate of 3 over 20 pi inches per minute.